So this is a follow-up video to today's assignment specifically, and how do we use these sigma formulas to help us simplify. So I'm going to just come back to that in a second, and we're going to focus on this particular setup. Now, what we're looking at is we're taking the result of what we get when we plug in our endpoint into our function. So this would represent the height of one rectangle at a specific x value, and then the width would be the delta x, and the width is going to be constant throughout for these types of problems. So after we did all of that, we're going to get an expression something like this. What do we do with that expression? So this expression, because we have some additions here, we're going to break those apart into three separate sigmas. Notice that all of this stuff is going to stay the same. And then I over 12n squared plus sigma. It's a little tedious. I squared 5n to the third. All right, so basically, it's not truly distribution, but basically each component gets its own sigma. Next piece. Now, I'm going to start incorporating some of the stuff from above. Okay, because we're going to look for some substitution. So the first component here matches up pretty nicely with this. All right, k is just a constant value. There's no n's, there's no i's, it's just a 5. So that part is done, it's ready to use. We're going to take the k and multiply by the n. That's the formula. So in this case, when we're done with this, I'm going to keep it as is for now, but when we're done doing these, this is going to end up being 5 times 5, or 25. Now, in the next problem, we have I over 12n squared. Now, none of these contain an n in the formula. So what we're going to do is we're going to take this one step further down here, and we're going to factor out anything that's not an I. And since they're in the denominator, I have to keep that in mind. You know what? I am going to call this 25. That's just a little quicker to write. So we know this is 25. And then on this next one, we're going to factor out that denominator. And we're going to factor out this denominator. And now we can start looking at these formulas. So in this particular problem, we wanted to take the n out of that because now this piece, this sigma, only has an I, and it looks identical to this. So now we can plug in the formula in its place. So it's n times, parentheses, n plus 1 all over 2. That's going to take the place of this, n plus 1 all over 2, and the front fraction remains. Keep the 25, and on this one, 1 over 5n cubed. I'm going to zoom out so you can see the formula. It's right here. So I'm going to save myself a little bit of work. I'm going to copy that, paste it down here. Now we have a formula, albeit complicated and kind of nasty looking, to find or to use the number of rectangles n, which will then give us the area. So 25 is good to go. I'm going to multiply here and multiply there. 24n squared. I'm going to distribute here n squared plus n. And then we have I'm not going to do all of this, but I am going to do this. This is 30n cubed top. Now I could keep going with this, but the idea is that we're going to start off simple. We're not going to have all three terms here. That's going to be reserved for when we start using our shortcut. So we could now plug in, let's say, 2. 2 is a reasonable one, right? So if I plugged in n equals 2, oh shoot, I used 5. Let's use 5. So if n were 5, now I'm going to plug in 5. 5 squared plus 5, 24 times 5 squared, plus 5 times 6 times 11 over 30 times 125. And if I calculate all of that, I will get the area under a curve, which I don't have, right, using 5 rectangles. The key to take away from this is this step right here and this step right here. When do we use these formulas and how do we use them? Let's do one more simple one to really drive home the point. Let's say I had I equals 1 to n, unknown number of rectangles, and my formula was 1 plus I over 2n squared. Much simpler problem. I'm going to do 1 to n of just the 1. We're going to do 1 to n of the I squared. No, not I squared, but I over 2n squared. This is just going to be n. Here, I'm going to factor out 1 over 2n squared. And this is what I'm going to substitute out. So I'm going to get n plus 1 over 2n squared times n plus 1 all over 2. And I'm going to figure out what all of this equals. So the top is 1 times this, so it's n squared plus n. The bottom is 4 over n squared, and over here I get n. And now I can really just plug in my 2 fairly easily. When n equals 2, we get 2 plus 4 plus 2 over 4 times 2 squared, or 16. So it's 2 plus 6/16